Proposition 35, Book 1, Euclid. If we have parallelograms in which they are in the same base and they are also in the same parallel, the two parallelograms are going to be equal to each other. Here we have two parallelograms. They both are at the same base and they both are in the same parallel. This line is parallel to this one. Well, we know from our bag of tricks that in any parallel line, the opposite sides are going to be equal to each other. Therefore, this side is going to be equal to this side. And this side is also going to be equal to this side. Okay, so now, we know that this is equal to this and this is equal to this. Therefore, this is equal to this. Now, let's add equal to both sides. Let's add this pointy line to both sides. So now we are going to have this and we are going to have this. This is equal to this because we just added both to both sides and we know that they both were equal. Therefore, this line is going to be equal to this line. Well, so here we have a parallel line. And here we have another line falling upon them, those two parallel lines. And we also know from our bag of tricks, that if we have a parallel line and another line falling upon this line, the external angles are going to be equal to each other. Therefore, we have here this angle being equal to this angle. We have that. So we already know that these two angles are equal. We know that these two lines are equal. We also know that these two lines are equal because they are parallel to each other. So here we have two triangles. This side being equal to this side being equal to this side, and their angles being equal to each other. Therefore, we are going to have side angle side. And we know that when we have side angle side, the triangles are going to be equal. Therefore, the bases are going to be equal to each other. So now here we have these two triangles being equal to each other. Now, here we know that these two have the two triangles have this part in similar. So we are going to take this and we are going to see that the remaining will be our parallelograms in the beginning. So here we have this parallelogram and this parallelogram being equal to each other because we took this and they were equal. Now the remainings are equal. So now we have this being equal to this. Let's add this to both sides. So let's add this to this side and let's add this to this side. So now we are going to have this parallelogram being equal to this parallelogram. That is what we wanted to prove in the beginning, that if we have two parallelograms in which they are in the same base and they are in the same parallelogram, the two parallelograms are going to be equal to each other. Proposition 35.